Okay, we're working on line P3 learning task 2, and this is the third video, and this video is going to be tough. It's going to be tough for you to follow because there's a lot of small similarities and differences between what we are going to be doing today from one connection that we're going to make over to the other. And what we're doing is we are working on Y to delta connections over here, where we have got a Y input and a delta output. But because we know that when we're making transformer drawings that we always have to draw the high side first, there are going to be two distinct connections that we are going to go and make. We're going to do them one at a time, but the two distinct connections that we are going to go and make are both going to go and require a voltage diagram. Let's put that down as voltage diagram, as well as a connection diagram that we are then going to go and create off of that. So do keep this straight. If you're into skipping and fast forwarding inside of the videos, make sure you keep track of which one we are looking at, because otherwise you're going to skip ahead 2 minutes, 5 minutes, half an hour, whatever it is that you do on your skips, and all of a sudden you're going to be like, what in the heck just happened over here? This is completely different and I'm so confused. You got to watch the full video to really understand what's going on. When we were doing Y to Y or delta to delta, we saw that our high side was connected the exact same way as our low side. But now we're going to go and get into some really different and in some cases super funky types of connections that we are going to go and have. The two sets of connections that we are going to go and have are going to be when I'm going from a Y high, because we're doing Y to delta, to a delta low. So in on a high Y, out on a delta low, or where I am coming in on a Y low and coming out on a delta high. Out on a delta high, in on a Y low. And you might be wondering why this makes such a big difference for us to, have to have two separate different voltage diagrams, to come in. But it's because we're always going to go and have to draw that high side first. This one, we'll start with the high side. Even though we're coming in on the Y on the low voltage side, we still have to start our diagrams by looking at our high side. Same with this one over here. We're going to go and start our diagrams with the high side. So before you start doing any diagramming, say, what am I attempting to do? Am I attempting to come in from a high Y and step down to a low delta? Or am I attempting to come in from a Y low and attempting to get up to a high delta? And based on what your input is going to go and be, you're then going to go and select which one of these diagrams you're going to make. We're going to start with the first one, which is going to be us working our way through creating a high Y to a delta low. So I'm going to start just by splitting a screen in half over here, and I'm going to go and say high and low, H's and X's that we'll have. I'll just move that one over actually. And then I'm going to go and have my Y and my delta is what my connections are going to be. So high Y, delta low. I'm going to start with that same set of rules that we've established before, which are going to be that we start with A as our origin on our high side, and off of the A as our origin, we're going to go and draw two imaginary lines. One is going to be off at 30 degrees, and that is going to be from A to neutral, the very first line that we draw, whether physically or mentally. And the second one is going to be off at 60 degrees, and it is going to go from A over to wherever I'm going to go and place my phase B. Draw these two in. Once you've got them drawn in, then we are going to go and start doing the actual diagram. So the first thing that we're going to do now that we've got the basis of the diagram, A neutral and A to B, is we can go and drop in phase C. We know where that thing's roughly going to go and end up. And now we're going to go and take a look at our actual connection that we have and say we're looking for a Y type of connection. So if we're looking for a Y type of connection, we're going to start with A, and we are going to go and feed in. Now, like we have done in the previous two videos there, Y and delta delta, we always start on our high side with the H1 of the associated one that we have. H1 and H1. The other thing that we are going to go and talk about is the fact that one, H1, I'm just going to draw it here in gray down below, and H2 had, at the very beginning of the module, they had specific things that they were. They were, as far as my phasers were concerned, H1 was going to go and be the tail. This is a drawing convention, and H2 was going to go and be the head. So on all of mine now, I'm going to actually start dropping in the arrowheads. They were not important when we were going YY or delta delta, but now that we're going to be mixing, it's super, 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 super critical that you maintain those little arrowheads. You'll understand why in a minute. Okay, we're going to start with our A phase, and our A phase, we see that we have an H1 already there. H1 is going to be the tail, H2 is going to be the head, and we know that our H1 is going to go across from our A to our B. H2. Oh, sorry, what am I doing? A to our neutral, because we're doing a Y side. I just lost track of where I was for a second there. So I'm going to start with my H1, and I'm going to go and take my H2 into the center. Then I'm going to go and do my phase B the exact same way. I'm going to take my H1, I'm going to take my H2 to the center, and then I'm going to go and take my phase C, and I'm going to go and take my H1, and I'm going to go and take it into my H2 in the center. At this point, I can go and label all the rest of these over here. So we're just going to make this one an H2, this one is a H2, and this one is a H2, like that. And now that we've got that labeled, the next thing to do is we are going to go and work on our secondary side. Now we know on our secondary side that what we're ultimately looking for is that we need to go and have a triangle inside of here. But we need to build the triangle out of whatever our primary side was built out of. In this case, it's built out of these three arrowheads at these three angles. So I'm going to draw right now my secondary sides. I'm going to draw the secondary sides as smaller ones, but I'm going to maintain the arrowhead. It's critical, this maintaining of the arrowhead in the same direction as what I have on my high side. Okay. So now that I have got these all laid out over here, we can see that my secondaries, that the smaller ones there, the arrowheads are in the same direction. What I'm going to do is now I'm going to go and pick these things up. Oh, no, not both of you. I only want you. Can I select? What? 1 second over here. All right, that was weird. I don't know why it wasn't letting me select the whole thing, so we'll just select one at a time here. What we're going to do is we're going to move these arrows over to the other side over here. And when we do that, we're going to go and use these arrows that we have to go and create a new triangle off of here. We have a Y on the other side. What we're looking to go and do now is we are looking to go and create a delta out of our opposite side over there. And what we want to do is we want to try and use these three arrows that we have to create a delta or a triangular shape that is going to be as close as possible with my A line. Note where my A line is right now. And note that my neutral section would have to go and be in the middle. Now we are going to go and have what's referred to as being a 30-degree phase shift. And we are always, always, always going to go and have a 30-degree phase shift anytime that we move over from a Y to a delta. The direction that that phase shift is going to go in is that direction is always going to go up. So right now, we're just going to go and grab a whole pile of these here. We're just going to move them out of the way. And then we're going to go and draw in where our neutral actually needs to go and be. So our neutral needs to go and end up at the same spot in the very center over there. And previously on our high side, we had A to neutral was at 30 degrees off the center. What happens now is that the neutral, A to neutral connection actually has to go and rotate up by 30 degrees. In other words, this angle here needs to go and rotate up. So we're just going to go and take our A point and we're going to move it up to here. Once we have got that done, we'll stick in a big A over here. We can then go and draw the rest of our triangle. I'm going to go and erase a bunch of this other stuff here. These arrows, we don't need them anymore. I'm going to erase this one, my original A. We've moved the A so that the A is in line with our neutral. And we'll just move that neutral just nice and close in there. Well, if I take a look on my high voltage side, I see that I have got the tail of my A vector connected to my A line. So I'm going to go and do the same thing with these arrows that I dragged over. Remember, this arrow used to go and be connected over there. Somehow it's still connected to that other one. That's super weird. We'll just go back into our lasso select. What I'm able to do now is I'm able to go and connect. So the tail connects over to my A. If I want to take a look at my B, I see that for my B, I've got the H1 connects to the B. So I'm going to go and do the same thing over here. We're going to go and get that tail, and we're going to connect it up to my B like that. And then for my C, I'm going to go and get the tail, and I'm going to go and connect it into my C line like that. And what we end up with is we end up with a triangle that looks like this. Now I'm going to draw the triangle a little bit bigger because that thing's super tiny and hard for us to go and work off of. But what I can really hope you see off of this is the fact that all the arrows are in parallel. We've used the same arrows in the same sort of configuration to build a triangle now, and we have gone and offset our A by 30 degrees. I'm just going to draw this thing now a little bit larger, just so that we've got a little bit of working room. And then we'll erase that little tiny triangle that we had over there. Perfect. Erase that, and oh, I erased them all there. 2 seconds. Okay, now that we've got this, we can go and put in our lines. So, sorry, that's a C line over here and a B line over there. And then I'm going to go and label everything. And we're going to label them, once again, I see that the tails are going to be the ones, but now we're low voltage, so this is going to be an X1. This would have to be an X2. This one is going to go and be a X1. This one's going to have to be an X2. And this one's going to have to be an X1 and a X2. Okay. We have now got a proper configuration to go over from my high side Y over to a low side delta. Let's go and place all of these drawings now. We're going to go and put them directly onto a layout that we're going to go and have over here for the actual transformers. I'm going to skip the next 2 pictures. We're going to come back to these 2, figure 33, figure 34, but we're going to jump ahead to figure 35 right now. Figure 35 is going to be for us to do what we just did over there, where we are going to go and have a Y high, which means that I'm going to go and have red, black, blue, and a neutral. We've got a high voltage bus, and we are using this to go and step down from one side over to a lower voltage bus over here, which is going to be a delta type of system, red, black, and blue over here. Once we have got all of our lines drawn in, we are then going to go and start making our connections. So refer back to the drawing that we just had. Let's start with the high side over here. The first connection we're going to do is we're going to say on our high side, all of our H2s are going to go to the neutral line. So on my high side, all of my H2s are going to go up to my neutral. High side, high side, high side, like that. Next thing I'm going to do is I'm going to say that my H1s are going to go to their line. H1A, H1B, H1C. So we're going to go back over to this one over here. H1A, H1B, and H1C. So now this high side over here is all in alignment with this one over here. The other thing that I want to point out is we are not going to put a ground onto this one because this is an existing system. It should have been grounded on the original install. We're not going to install duplicate grounds. We're not allowed to go and do that under Canadian electrical code. So because we're tapping off of it, we don't have to worry about putting a ground onto it because the system is already grounded. We would only have to ground any new systems that we create. And if we take a look at the system we're creating is not going to require a ground. The system we're creating, we're going to go and step through now. If we take a look, I see my A line connects to my X1. My B line connects to the X1 of the B phase. My C line connects to the X1 of the C phase. So I'm going to start with that. A line X1 connects to the A phase. B line X1 connects to the B phase. C line X1 connects to the C phase. Simple enough. And then I go over and I take a look and I see my A phase connects across from my A. The X2 of A goes to B. So A goes to B. The B phase goes to C. The C phase goes and circles back to A. So our A phase is going to go and connect over to B. Our B phase is going to connect over to C. And our C phase is going to connect back onto A. Double check your connections. You should count no more than 2 connections per line on a delta. 2 on this one, 2 on this one, 2 on this one. If there's more than 2, guaranteed that you screwed up. If there's less than 2, guaranteed that you have screwed it up. It's just a quick way for us to go and check. This is our additive transformer bank. And the next couple of pictures, 36, 37, step you through what we just did. And if you take a look, theirs are the exact same as the one we drew, just a little bit neater and with no colors that are associated with it. Using additive polarity transformers is possible. Using subtractive polarity transformers is possible. Once again, my high side, done identical. I'm not going to go over top of that one. My low side, I see that I'm still going to be x1s to A, x1s to B, x1s to C, and then A goes to B, B goes to C, and C goes back up to A over here, which is fine when we're doing subtractive ones. And I can even go and use mixed. Now here is an issue. The issue is that one of these is screwed. I'm going to just hold my breath for a couple minutes, and you try and figure out which one it is, and we'll go over that. All right, enough time. If we take a look at it, you should have figured out the fact that on the high side, everything looks really, really good over there. But on the low side, we have got an issue in the fact that our A transformer, X1 of A should be connecting to A, and X2 of A should be going across to B over there. Uh-oh, there's an issue there. The rest of these are good to go. If I take a look at, B, my BX1 goes over there and connects across to C. My CX1 connects to its line, connects back to A. That's all good to go. But the very first transformer over here is screwed up. Let's go and reconnect that transformer. It should have X1 to A, and it should go and have its X2 going down to B over there. Scratch out the lines that they had inside of the book, white them out, whatever it is, but make sure you make that correction, because otherwise later on when you're studying, particularly before a midterm or final, you're going to not remember what's going on and just wonder what exactly happened. Okay, this is now where we're going to go and change gears again. We have done our Y to delta connection when we are doing a step down, when we've got Y high and delta low. What we are next going to go and do is where we are going to go and have a Y low, and we are stepping up to a delta high over here. And this is the hardest connection out there. Hardest, just like that, okay? Absolutely the hardest connection to go and deal with, because it's got some real jankery going on inside of here. It works, it's correct, but it just looks and feels wrong, okay? Let's go and take a look at how we lay this one out, and we'll explain it as we go along over here. First thing that we're going to do is we're going to go and say we are going from a Y to a delta. And the delta is on the high side, the Y is going to be on the low side. Now, am I allowed to go and start drawing over here on the low voltage side? That is not allowed. If you start with the low side, guaranteed you're going to screw this whole thing up, okay? Even though the Y is going to be, the low side is going to be my feed in, we're still going to start by drawing the other side first. And the other side is always going to be drawn according to the same rules. This is wonderful. These rules help us a lot. Those rules are going to be that from A to neutral is always going to go and be 30 degrees, and A to B is always going to go and be 60 degrees. Okay, we've done that a ton of times. So now we know where our neutral is located. We know where our B line is going to go and be located as well. And we can now go and get rid of these. Okay, my high side is a delta, which doesn't actually have a neutral. The neutral just exists in the very middle, and all the voltages are automatically balanced around it. So we can go and draw out our third missing line over here, C, and now we can go and make our connections. As with everything else, once again, H1s are going to be associated with the actual proper lines. So the H1 of C, the H1 of B, etc. And we can go and draw out proper arrows for each one of these. If I take a look at A, the tail is going to start here, and it is going to go and terminate on B. And I'm going to make sure I put those arrowheads in. The B, H1, is going to start there, and the tail is going to, or the head is going to terminate on C. And the C, H1, is going to start over here, and the head is going to go and terminate over here on A. And once we've got those in, we can finish up doing the rest of our labeling. H2 and H2. Okay, high side is done. Nothing new has been involved over here. What's going to happen is we are going to have to now transfer to the low side, and once again, as we said with the previous connection, anytime that we go and have a transfer from Y to delta or delta to Y, there is always going to be a 30-degree displacement in where the A to neutral was. In other words, originally we had A to neutral like that, and now we have to go and rotate that up so that my A to neutral is going to go and look like that. So since we know that we have this, it is a law, it is a rule, you can't fight it, don't fight it, just accept it. Since we know where that A has to get moved to, and since I know where my neutral is, that is going to make my connections on the other side a lot easier, because I know where I've got A and I know where I've got neutral, and as soon as I have got my A and neutral, I'm just going to go over top and write A again. Oops, sorry, that's an N. I'm going to write A. I'm going to go and write B, because if my neutral's there, I know that my B is going to have to be up here, and I'm going to go and write C. I should change my colors over here. We'll write B up here, and we will write C down here. And I've got my neutral in the middle. We are now going to be able to make some much better connections. Okay. Let's go across to the other side again. We're going to draw in the secondaries of each one of these windings, and the arrowheads are critical. Okay, we got a high voltage. We're going to go and have a low voltage, and I'm going to put that little arrowhead on it in the same direction. High voltage, low voltage, arrowhead on in the same direction. High voltage, low voltage, arrowhead on in the same direction. You should be able to see that these are all the exact same lines. Now what we need to do is we need to go and take each of these individual components here, and we have to take all three of these and carry them over onto this side, and then we have to form a Y out of them. It's going to get a little bit weird because ultimately I need to go and have all of my arrowheads need to go and be pointing. Well, and not quite the way that we think that they're going to go and be pointed, but we need to be able to go and make those connections going across from one to the other. And this is where this is going to be super weird now. Oop, let's go back to that lasso select. If you take a look at it, I see that I need to have a horizontal line between A and neutral. And so I'm just going to play this real simple game called, what is a horizontal line? Is that a horizontal line? No. Is that a horizontal line? No. Is this a horizontal line? Yes, it is, and it disturbs me because it's the C horizontal line, but it's the only one that fits inside of that place. So I'm going to place it over there. The next thing I'm going to do is I'm going to say what is going to be a line running up here roughly at about 60-ish degrees. Does that one run up there? No, it doesn't. Does this one? Absolutely it does. So therefore, this one is going to have to go up top over there. And then I'm going to go and look from my neutral down to C. There's really only one line that fits the bill, and that is going to be this one over here. And so we end up with something that's going to look a little bit like this, or a lot like this. I'm going to go and redraw it, okay, just with bigger, better arrowheads there so that it's a little bit easier for us to go and look at. I'm going to go and keep my neutral point in the center. I'm just going to remove the end for now. I'm just going to redraw each of those lines. Remember, we had a blue line, which is a C-phase winding over there with an arrowhead pointing out. Then we had a red line with an A-phase winding with an arrowhead pointing out. And then I had a black line with a arrowhead pointing out like that. Okay, arrowheads, are those 2s or 1s? 2s. Excellent. Thank you, class. Those are all going to be 2s, so I'm going to go and label them all as being my X2s. X2, X2, X2 over here. And if I've got all the X2s labeled, that means the opposite end has to be my X1s. X1s. And X1s, like that. So we've got line A, line B, and line C that are all labeled up here and ready to go. I'm just going to move this guy just a hair over there so it lines up. Perfect. This is my voltage diagram. It feels super wrong because the first thing that you notice is that we've got an A phase, but we're building that A phase out of this B phase. You know, it just feels really wrong to do it. However, it's not wrong for us to go and do it. It's the only way that we can create this. So what we're going to do right now is we're just going to go and swallow that. We're not going to deal with, you know, the fact that we feel upset by it. We're just going to go and make connections across onto the other side. Okay, we said that we were going to be feeding in on the low voltage side. The X, we're going from a Y. Feeding in on the low voltage side, we're stepping up to a delta on the other side. So we're going to start by making all of our connections onto that same one. What we have over here is they don't give me a blank set of transformers to go and draw over top, so we're just going to work with the ones that they have over here. But it's the same connections that we're seeing. We're going to start with, actually I am going to go and grab this one over here. 2 seconds. We're just going to throw in a new slide. It's just better for us if we go and draw the whole thing out there. Paste this one in here. Okay, just ignore on the very bottom of this thing where it says that it is a figure 35. We'll just cross that one out there, and then we shoot, no, it's still not going to work. Never mind. I thought I was onto something. It's really not going to work out. We're just going to skip past what I was doing, because over here what they've done is they've drawn the input side on the high side, and we'll start by making our input side. We'll just go over top of their lines that they have with color so that it's easier for us to go and see. Okay. We are feeding in on the low voltage side, so we're drawing our feed at the top. We're taking our output over here at the bottom. Let's start with that low voltage connection. If I take a look at my low voltage connection, I see that my low voltage connection is all of the X1s. So I'm going to go back to this one over here, and I'm going to go and take a look at my low voltage connection. I've got a X1 for my A phase going up over here. Actually, I'll draw that one in the gray. It makes more sense with what we've been doing here. X1 of the A phase, X1 of B phase, and X1 of C phase. Now you'll note that the A, B, and C is backwards, or seems backwards compared to everything else, but that's because anytime that we're looking at a transformer, here I am, here's my arms, my A should always be on the right-hand side when I'm looking at the high voltage side, okay? That's why it's reversed. Before all of these drawings were flipped around the opposite way, you can see that if I flip this drawing 180, that the A would end up back over here on this side. We're not worried about that because we understand it. So I've got all my X1s on the low voltage side that are going to go and be connected. Then I'm going to go and take a look at where my X2s go. And this is where it gets really kind of funky. If I take a look at line A, it gets X2 from C. So I'm going to go back down here. I'm going to go and take a look at line A over here, and it is going to go and get X2 from my C phase transformer over here. If I go over to my next one, I see that I have got my line B gets X2 from A. So my line B is going to go and get X2 from A. And then if I go and take a look at my line C gets X2 from B. So line C is going to go and get X2 from, here's my B, so here's my X2. Okay, it is paint by numbers. We are just doing what we saw we had before. That takes care of my my low side connection, my input side. The other thing that we're going to do is we're now going to build our new system on this side here. Red, black, and blue going across here. And then we're going to just go and take a look at what we have for actual connections. This side's going to feel much more friendly to us because it's going to be us utilizing what we have for regular connections. If we take a look, we see that we have got our A1, our A transformer, our B transformer, and our C transformer. I see that H1 of A goes to line A, H1 of B goes to line B, H1 of C goes to line C. Let's chip those ones off first. Find my A transformer, H1 of A goes to line A. H1 of B goes to line B, H1 of C goes to line C, like that. Once we have those connections across there, then we are going to go and take a look at the other ends. We see that the A crosses to B, terminates on B, B terminates on C, C terminates on A. So we're just going to go and follow that through. We see that A terminates on B, B terminates on C, and C terminates on A. And that is now going to go and be my that's now going to be my high voltage side, my high voltage delta that I would have over here. You can go and compare this drawing to your figure 41 inside of your book. Figure 41 is what they show inside of the book there. What we have over here is identical to that figure 41, just we're once again inside of color over here. As before, we can go and use different polarities of transformers. We can go and use subtractive transformers. Note once again that my A, B, and C are all the way across off of these ones here. Subtractive values of transformers that are being placed across here. But once again, going through that same setup that we have, it's going to be the exact same layout that we are going to go and be following, where we're going to have X1s tied together onto a neutral. X1s are going to be tied together onto a neutral here, here, and here. And then we are going to go and have X2 of C going to A, X2 of B going to C, and X2 of A going over to B, which is what we had over here. C goes to A goes to B, B goes down to C. Delta side, simple enough to go and take a look at the connections as well. H1 of C goes to line C, H1 of B goes to line B, H1 of A goes over to line A as well. That's going to be using subtractive polarity transformers. The other way that we can go and do it is us working off of mixed polarities. Once again, we're going to go and take a look at our Y side first. All the X1s are going to go together onto the same line. So I see that I've got this is a delta closure test. I skipped ahead of myself there. There we are. This is the mixed polarities. All of the X1s are going to the same line, same line, same line. And then going back into here on my X's, I see X2 of C goes to A. So X2 of C goes over to A. X2 of B is going to go over to C. X2 of B goes over to my line C. So we're going to draw that one in. And then X2 of my A is going to go to my line B, which is going to be this black line over here. Same as what we had over here. We're just copying numbers and making connections based off of this. Even though it seems confusing to have to, go mix polarities and delta Y and all this other stuff, as long as we have these diagrams, you cannot screw up if you just copy where the numbers and the arrowheads themselves are. Then if we take a look at our at our delta side, we see that the delta side, we should always have the H1 that is going to be associated with it. So I see H1A together, H1B together, H1C together. And if I take a look at this one over here, I see that I have got H1 of B onto here. I see that I have got H1 of A onto its line. Remember, the A is on this side because we're standing over here and looking at this one. And I've got my H1 of C, which is going to go across to here. And then going back to this one here, A goes to B, B goes to C, and C goes to A. So I'm going to go have my A, which is going to go to B, B, which is going to go over to my C, and then my C, which is going to go back to my A over here through my H2s. Subtractive, additive, once again, mix and match these things. Just make sure that you're doing the terminations to this diagram that you have over here. Okay, last thing that we're going to talk about is that we should do our closure test anytime that we're creating a delta system. So we went from a Y to a delta. This is a step down application rather than the step up application. But either one of these. What we're going to be looking for on that last closure test is we are always looking for a value of voltage that is going to be equal to 0 technically it should be 0, but it's going to be 0 to line value of voltage. And anything that's 0 to line value of voltage, we consider to be good. Anything that is going to go and be 2x, double my line voltage, that is going to go and be bad. We don't want to go and see that. If you get double line voltage, you've got one of your connections inside of here mixed up. Okay, that's a half hour of your life. It is a confusing half hour. It's not really that it's so confusing, but it's just work. You got to keep this stuff straight. We are going to go and take a look at our last connection, which is going to be my delta to y, and that delta to y is really going to involve us drawing out the same two diagrams, but on the last video, or sorry, second last video, we're going to be feeding into the delta side and coming out onto the y side.